Hi, this is Mrs. Kelly, and in this video I'm going to show you about functions. A function is a type of relationship or relation where each input has only one output. The second part of that sentence is really critical to understanding what a function is. Each input, so every single thing in the input or the domain, only has one output. There are 5 ways to represent a function: 1 with a mapping diagram, 2 with a table, 3 with an ordered pair, or you can call it a point. And we normally label our points with the x value, comma y value in parentheses. And then a graph is the 4th way, and then the 5th way is with an equation. These are all the ways we've been represented it so far, and it's how we'll continue to represent functions as we move forward in the year. So for each one of these, I'm going to take you through some examples of things that are functions and also show you some examples of things that are not functions, so you'll be better able to tell them apart. First, for a mapping diagram, in this diagram here we have the input and the output is the second circle. The first circle represents the domain, the second circle represents the range. In this circle we see that 1 only has one output right here, 2 only has one output, and 3 only has one output. This mapping diagram happens to show the doubling function. Notice that 1 is double to get 2. 2 is double to give you 4, and then 3 is double to give you 6. That's the doubling function. This is an example on the right side of something that is not a function. For example, here with A, we see that A goes to both 1 and to 2. So here we have an example of an input which goes to more than 1. This is 1, and this is 2 outputs. Anytime one input splits apart to more than one output, it is no longer a function. It violates the definition of a function, only ever having one output for each thing. Okay, so be sure to look out to see if any of your inputs splits apart to more than one output. And that's one way you'll know for sure it is not a function. Next, we will look at a table. So on this table, again, I use the doubling function. So notice 1 doubles to 2, 2 doubles to 4. But I changed it up so that you see that 3 in this example goes to 2. Now in this case, it is okay that the 2 in the range repeats itself. So here and here we have 2, but that's okay. And I'll show you with a mapping diagram why that's okay. If I were to make a mapping diagram of this function, okay, I will have 1 connected to 2, 2 is connected to 4, and 3 is also connected to 2. Now even though 1 and 3 both go to 2, it's okay, because if you go back to the definition, each input here, so 1 only has one output, it goes to 2. 2 only has one output, it goes to 4. And 3 only has one output, it happens to go to 2 as well. And that's okay. As long as each one of these only goes to one thing on the output circle, we're good to go. It follows the definition. However, on the right side, let's look at something that's not a function. So here we have something in the domain that repeats. We have 2 10s here. Now this will show you that it is something here that's causing your X to have 2 different outputs. So if we were to make a mapping diagram here, I would have 10, and in my output circle, 10 goes to 20, and from the next column of my table, the next row, we have 10 also going to 30. So since 10 splits apart to 2 outputs, this is not a function. Okay? So one trick when you have a table is looking out. It's okay for the range to have multiple numbers that are the same, But here it is not okay if you see something in the domain that repeats itself. Next, we're going to do ordered pairs. So again, looking at the ordered pairs, we see that there aren't any x values. Keep in mind each ordered pair, it represents an x, comma, y value. None of the x values repeats itself. I have a 1, a 2, and a 3. Again, if I were to map this out with a diagram, 1 goes to 2, 2 goes to 4, and 3 goes to 4. And like we described before, this is perfectly okay because 1 has only one output, 2 has only one output, and 3 has only one output. They each only have one output, so it fits the definition of a function. On the other hand, if I look at this non-example, we have a problem here because here we have a x, comma, y, but there's some x's here repeating itself. Okay, so let's show you what that means again. Here I have 10 breaking apart to 5, and 10 is also going to -5 in my output circle. So whenever you see the x's repeating, you know that it's not going to be a function as you're looking at ordered pairs. Okay? Next, we're going to do graphs. Now with a graph, there's a special way to check to see if something's a function, and it's called the vertical line test. A vertical line test means I can take a vertical line and it would only ever hit my graph at one point. If it hits my graph at more than one point, it's not a function. So here's an example of a graph where you have time on the x-axis, and on the y-axis you have salary. It's a linear function. We've been doing lots of this type of equation and function in the past. So look at what happens if I draw a vertical line. It only hits here at one point. If I draw any other vertical line anywhere along my green line for this function, it only hits it at one point ever. That means for each x, there's only one y as my output for this line. So this does pass the vertical line test. However, if I were to look at something like this sideways curve, and I were to check it with the vertical line test. Now, although right here I could draw a vertical line and it only hits one point, it has to be true everywhere on this curve. So the minute I make a line, let's say right here, we have a problem. It's going to hit 1 and 2 points. So that means for this x value, there's a y here and a y here on that function, and that will not be in a function at all. So this is not a function. And the reason why it's not a function is because it would fail the vertical line test, or you can think about it this way. There's one x value or input with more than one y output, so it fails by definition of being a function. Okay? And the last example is by looking at an equation. So all the equations we've done for the year so far falls under the umbrella of being a linear function. Okay? All of them so far this year are linear functions. So an example of that would be y equals 5x plus 2. So you would start at 2 on your y-axis and continue to increase up by 5. So if I were to make a vertical line and check this equation, now that I have that equation graphed, it would definitely pass the vertical line test. And I could look at this and see that this is in fact a linear function. However, here's a non-example. This is an equation of a circle, x squared plus y squared equals 16. It happens to be a circle with radius of 4. So again, looking at the graph of it, once you've graphed it, you can see with a circle, if I made a vertical line, it would hit 2 points. Okay, so for that value of x here, there are 2 y's or 2 outputs for that same input of x, and that violates the definition of being a function. So I've just taken you through all 5 ways of representing a function, and I've shown you both examples and non-examples so you can tell a function from something that's not. So hopefully this will help you identify functions and refresh in your mind the different ways we've been representing functions in class. Thank you for watching.